Welcome to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck, and this is episode 3 in our crash course on factoring. Today we're going to be looking at situations like this, where you have a coefficient in front of x squared that cannot factor out. You can see in our last video how you can sometimes factor out common multiples from everything, allowing you to factor more easily. In this video, you're going to see that there are situations where that's not possible. You can see here, normally we would try to divide this by 2, but 5x doesn't divide by 2. 3 doesn't divide by 2. So we're going to have to find another method to factor this. And you can see right away that our old factoring method won't work. Before we had taken the third term, and we try to find things that multiply to make the third term, but add to be the middle term. And you can see here that there's nothing, no whole numbers at least, that will do that. So 1 and 3, that adds to be 4, not 5. So this actually isn't going to work. We're going to need to come up with some new strategies. So walk with me today and see if you guys can learn this new method. The first step that you need to do in order to factor something like this is to multiply the first and third terms together. So you're going to take 2 and multiply it times 3. If you do that, you're going to end up with 6. And we're going to do the same thing we did with 6 that we used to do with just the third term. So we're going to take 6, and then we're going to see what adds to be 5. Now this is going to be a little easier because one of them will actually work. 1 and 6 doesn't work, but 2 and 3 does. Now, the danger with this, a lot of my students will try to just jump right from here to the answer like you used to be able to do. You can't do that. Be really careful here. It's a really common error I see, particularly in my older classes that try to forget factoring. And you can see that this doesn't work. If we try to do that, you end up with x plus 2 and x plus 3. Remember, every time you factor, you can always know if you did it right by multiplying this back out. If you do this here, you'll see right away that you're not going to get what you started with. X times x gives you x squared. X times 3 gives you 3x, 2x, and 6. You can see without doing any simplification that I don't have the same thing. I end up with 6 instead of 3. I have x instead of 2x, or x squared instead of 2x squared. It's not the same thing. In fact, the only thing that's the same is the middle term, and that's going to be a problem. So this won't work. And so if you're checking your work, you'll see right away that this isn't going to make sense, and you're going to have to go with our other method. All right, so let's finish up our new strategy here. So we found 2 and 3 are our factors. The next step that you need to do is to split the middle term up into those pieces. We're going to change 5x into a sum of these two numbers. Again, sum means addition in math. So 2x plus 3x. And then once you do that, you just rewrite the entire problem. So the only thing that's changed is we've split 5x up into its pieces. Then what we want to do from there is going to be very similar to our last video. We're going to be trying to find common multiples. We're just going to do it twice. I'm going to put parentheses around this first pair of terms and parentheses around the last pair of terms. And there should be a plus sign between them. Make sure that there's a plus sign. If there isn't, you did something wrong. Once you have the parentheses, see if you can find the greatest common multiple that goes into both terms. So if we look here, you're going to see that I can divide both of these by 2. But I can also divide both by x since they both have an x in them. And what I'm going to do is factor those out. I'm going to undistribute 2x from both. So if I undistribute the 2x, I'm left with 2x times x, because 2x squared divided by 2x is just x, and 2x divided by 2x is 1, so I'm left with a 1 here. Over here, the biggest common multiple is 3. Both of these are divisible by 3, so I'm going to factor or undistribute a 3 from both of those. which is going to leave me with 3 times x plus 1. Now this next step is kind of cool, but you kind of have to be careful about it. I want to do it one more time. I have a new set of terms, and I want to take the greatest common factor out of what's left. Now here's the crazy thing. Just like before, I had 2 terms, but they're just bigger now. That's one term, and that's the other term. And I want to look for the greatest common factor between these two. The greatest common factor is actually going to be this entire parentheses, this entire binomial we talk about in math. So I can actually factor out the entire x plus 1. Just like here, the greatest thing that went into both is 2x. I can divide evenly. In this problem, I can evenly divide 3. In this problem, I can evenly divide x plus 1 and x plus 1. So I'm going to undistribute both x plus 1s. And if you see what you got left, you've actually finished. So the x plus 1 is going to go on the outside. What's left is a 2x from this first term and a 3 from the other term. So this whole thing is now factored. I know there's a few more steps to this, but we're going to do a few practice problems, and I'd recommend if you're taking notes on this, go ahead and write down the steps as we do them. All right, here's our next problem. You see there's some negatives in here. We're going to have to be a little bit careful to avoid any problems with that, but we're going to walk through the exact same strategy we did last time. So we have 3 and negative 2 as our first and third terms, and just like last time, we're going to multiply those together. So we end up with negative 6, and that needs to add to be negative 5. Now remember, when you have two numbers that multiply to be a negative, you need to have one that's negative and one that's positive. So we can try this. And negative 1 and positive 6 doesn't add to be negative 5. But we can switch up the negatives and make the 1 positive and the 6 negative. That right there adds to be negative 5. So our next step, once we find these factors, is to split up the middle term into a sum of those two numbers. So instead of negative 5x, I'm going to put a 1x here and a minus 6x there. Now we're going to rewrite the rest of this problem. So 3x squared goes right there, and negative 2 on the end. All right. Now that we've done that, our next step is to find some common multiples. So we put parentheses around the first 2 and parentheses around the second 2. But I see a problem here. Remember I told you there always needs to be a plus sign? What I need to do is make sure that this negative is inside the parentheses. And I just put a plus sign there. Remember, adding a negative is the same as subtracting, so I didn't actually change anything by doing that. But if you ever see this second term be a negative, make sure it's inside the parentheses. You're going to have some issues later on. So now we find the biggest common multiple in each parentheses. In this one, the only thing you can divide out is an x. You can make it a 1x if you'd like. Again, we undistribute that to leave us with 3x plus 1. And over here, the greatest common multiple is 2. So we can factor out a 2. We're left with a problem again. Negative 6x divided by 2 is negative 3x. Negative 2 divided by 2 is negative 1. Remember, these two parentheses need to be the same so we can factor them out. And they're not. Let's see if we can change what we factored out in order to make these two parentheses the same. So I'm left here, I can divide out a negative 2 instead, and that's actually going to fix my problem. If I factor out a negative 2 here instead, negative 6x divided by negative 2 becomes a positive 3x. Negative 2 divided by negative 2 is a positive 1. And now my parentheses are the same. They have to be the same or this process doesn't work, because the next step is to factor out the entire parentheses. And I want to undistribute the entire parentheses here. So I'm going to go ahead and do that. Again, I can't do that unless they're the same. So that leaves me with 3x plus 1 on the outside here, the parentheses has been factored out. And what's left is my x and negative 2, and that forms the rest of the parentheses here. Again, I'd really encourage you to multiply these to check to see if it gives you what you started with. If it doesn't, then you need to check your work. I can tell you right now, though, that this is correct. All right, we're going to try one more here, and it's going to be a little bit more difficult yet. So here's our last example, and walk through this together. If you want to try this one on your own, I'd recommend it. You can hit pause and check at the end to see if you got it right. But for those of you not pressing pause, I'm going to walk through it with you. So we're going to start by multiplying a and c together to get negative 18. And it needs to add to be negative 7. Again, since it multiplies to be a negative, I know 1 is negative and 1's positive. There's a couple possibilities. We could have 1 and 18, but I don't see how that's ever going to be 7, so I'm not going to keep working with that. I can try negative 2 and positive 9. Now that's close, because that would be positive 7, so I'm going to switch the negatives around, make the 2 positive and the 9 negative. And that's going to add to be negative 7. So now that I have my factors, I'm going to change the middle term to a sum of those two. So I'm going to have a 2x minus 9x. Rewrite the entire problem. Start setting up your parentheses. And find the first two factors here. And then again, remember the negative should go inside the parentheses. And there should be always a plus sign between them. So be really careful about that. Find your greatest common multiples. In this one, both have an x in them, by the way. This first parentheses is almost always going to have an x in it. So look for that. And I can also divide out a 2. So I'm left with 2x times 3x plus 2x divided by 2x is 1. And over here, I could divide out a positive 3, but I remember from last time that I want it to be the same as this parentheses. So what I want to do here is divide by negative 3, which leaves me with a positive 3x and a positive 1. Now, since I have the same thing in both parentheses, I can take the entire parentheses and factor those out. I can undistribute that, which is going to give me 3x plus 1 on the outside, and the two numbers that are left are a 2x and a minus 3. And you're done. So again, walk through the steps, multiply the first and last together, rewrite the middle term as a sum of those two numbers, find your greatest common factors, and then factor out that last parentheses. If you follow those steps, you can factor almost any quadratic expression your teacher can throw at you. There are situations that you can't factor, but we'll address that in another video. Stay tuned next time. We're going to be talking about special cases. A couple things called difference of squares and perfect squares. So stay tuned for that, and I'll see you next time.